Just wanted to give a little update here on the 47 amp hour grid charger. This is the Mega Monster grid charger here. This charges at up to about 1500 watts at 240 volts, and at 120 volts it's looking more like 1100 watts. I was thinking it'd be 900, so pretty good. This will charge the 60S Fomico in 5-6 hours, so pretty cool. What I had to do though is, if you remember the larger heatsink that we added on the latest PCB here, this was to control the fast grid charger, which this is faster than. The fast grid charger was outputting 2.1 amps. I think I have one right here. Let me grab it real quick. So this is the fast grid charger, and again, it's outputting 2.1 amps. So up to about 480 watts or so. This is 3 times more power than that, and so it does require a lot more input current. And that fast grid charger that I just showed is about maxing out this triac here, even with this heatsink here. And a lot of that is because there's very limited airflow here. There's a cover, of course, that goes on top of it. And so any airflow we get in here, we have a laminar airflow that's going through these 3 fan holes, and we just have a turbulent airflow here. It does help a lot, and it works just fine with the fast grid charger. But with the Mega Fast Grid Charger, whatever, I have no idea what it's called, it pulls too much current. It's pulling up to about 11.5 amps on the input side, whereas this is only working up to maybe about 6 or 7. It just gets too hot after that. So the way this works is we have a triac pre-driver here that's driving this triac, and I just have it configured to where I'm using this triac to drive this triac. And so it uses the same harness, and this will ultimately be inside of here. I had a little problem. I was using some old, really old, like, they're actually like mica. I've lost all the parts, but they had a insulator on them that was not rated to even 240 volts. And so I couldn't figure it out because I was like, this circuit is super simple. It should work. Here's the actual circuit. And so we're basically using the triac that's on LiBCM to drive this triac here externally. And that's this triac right here. And so this will ultimately be attached on the inside of this power supply. I have another blocking diode that's attached on this side. So this is going to be non-standard. You can't just buy this off the shelf and have it work. Both the input and output sides have some TO220s on them that I've added. And so yeah, this external triac is basically going to sink its heat into this aluminum heatsink. So rather than going through a really thin copper layer and then going to a heatsink that has very poor airflow, it's going to sink into this chassis here. This chassis is going to be bolted to that last part that I'm missing, which is annoying, but it should be here soon, I hope, and then I can start shipping these out. But anyway, this not only will have this huge aluminum heatsink here and the heat plate underneath it, and that will actually go into the angle aluminum brackets as well. It will also have a fan that blows across it as well. So we're going to have one of these fans here blowing right across this heatsink, so it's going to work just fine. But yeah, again, the problem I was having is that these 40-year-old insulators just were failing when you'd put 240 volts through them, and I didn't know what they were rated for. Anyway, long story short there, right now I'm just sinking the heat into this bar here. It is high voltage when it's plugged in, so you gotta be careful with that because you don't want to touch it, hence my little safety sticker there. So what I've done is I've turned on LiBCM here. This is not running a stock firmware. I've modified it just for this testing here, and I'm gonna go ahead and plug in. This is my line cord here. So this is just the standard 120 volt plug. And when we plug it in, it's gonna power up. And this is all now energized, and you can see that we have the grid charger circuit is on. So this triac is now driving that triac, and then this is just sinking into my car. I just have it plugged into the actual battery. And you can see it's totally silent, there's no fan. You can see we're pulling right now 11.1 amps. Power factor on this is basically 1, which is nice. And we're pulling down to 113 volts. This supply does start throttling. So if I plug this into 240 volts, I'll get less input current, but since the voltage is twice as much, I'll actually get a lot more power output. Right now our power is only 1,258 watts. I'm still trying to reconcile why the cover here, this is the cover of that power supply, says rated power is 900 watts for input between 100 and 120 volts, and then 1500 watts higher. That's probably a heat related issue, and it doesn't matter. We can definitely control that. So we have a secondary PWM train here, and that can basically control. This has quite a few circuits we can control via a 8-position connector right there. We can actually turn it on and off. We can see if the power is okay. We can control both the voltage and the current, which is pretty nice. But we're actually only going to be using the voltage control. It's going to be a secondary safety. So this primary, of course, we can switch the triac here on, but triacs like to fail shut. And so it's nice to have a secondary control where we can actually adjust the voltage. So when the battery is fully charged, we will first turn this triac off, and then we will also set the output voltage to something really low. You can only set it down to 50%, so you can only set it down to about 120 volts or whatever, which is just fine. You're not going to charge either 48 or 60S at 120 volts. So it is double redundant safe. If LiBCM had a little more I/O on it here in the safety high voltage side, then I would also control the power enable. There's actually a power enable on here. And I definitely thought, instead of having this external triac circuitry, I definitely thought, well, I'll just control this power enable, no big deal. But it ends up being negative logic, and if we did that way, which we're not doing that way, but then if you had the firmware set in correctly, you could overcharge the batteries because they would be negative logic. So with the fast grid charger, what would turn the grid charger off would actually turn this one on. LiBCM could figure it out and say, hey, look, the voltage is still rising rather. But I didn't want to run into that risk, so we're going to have this external triac. It's going to be externally soldered on inside of this power supply. At the end of the day, it'll just be the same 4-position connector, and this is just prototyping. These wires are much too thin to be pulling 11.2 amps. So anyway, no real point to this other than that this is going to be the final thing, is a triac driver driving a triac, which is just fine. Looks pretty good. So as always, thanks for watching.